Hello दोस्तों, in this video we will learn about different type of matrices. So first is row matrix. So in row matrix, number of columns are n and number of rows are only 1 and 1. So n can be any natural number 1 2 3 4 5 6 up to infinity. This is an example of row matrix of order 1 into 5. Second is column matrix, in which number of rows can be n and number of columns is only 1. This is example of column matrix of order 4 into 1. Third is singleton matrix, in which number of rows is equal to number of columns and both are 1. So total number of elements in a singleton matrix is 1. This is example of singleton matrix. And fourth is square matrix. Square matrix is the number of rows and number of columns are both equal. That the order can be 1 into 1, 2, 2, 2 into 2, 3 into 3 up to infinity. And the total number of elements in a square matrix is n square. And total number of diagonal elements in square matrix are n, where n is order of square matrix. Fifth is zero matrix. Zero matrix is a matrix whose elements are 0, means all the elements are 0 in a zero matrix, and it has no relation with order, because a zero matrix all elements are 0, so no matter in taking the order. So sixth, the diagonal matrix. In diagonal matrix, so first of all, first condition for a diagonal matrix is that it must be a square matrix and all elements other than diagonal elements are 0. So all the elements other than diagonal elements are 0 in a diagonal matrix. And order of diagonal matrix is n into n because it is a square matrix. So same number of rows and columns. Total elements are same, n square. And diagonal element, number of diagonal elements are n, where n is order of matrix. And minimum number of 0 in a diagonal matrix is n square minus n, and maximum number of zeros can be n square. Then comes triangular matrix. The triangular matrix can be of two types: upper triangular matrix and lower triangular matrix. In upper triangular matrix, the lower diagonal elements are 0 and upper diagonal elements can be any number, and the lower diagonal elements are 0. And in lower triangular matrix, the upper triangular diagonal elements are 0. In lower triangular matrix, upper diagonal elements are 0. Then comes scalar matrix. In scalar matrix, it is a diagonal matrix whose each diagonal element is same, means all the diagonal elements are same. It is a scalar matrix. So basically, scalar matrix is also a part of diagonal matrix. Then comes identity matrix. It is a diagonal matrix whose all diagonal elements are 1, means the diagonal elements are 1. For example, 1 and 1, 1, and 0, 0, 0, 0. So it is a identity matrix. And these are some of the properties of identity matrix. Identity matrix raised to power n is always identity matrix. Identity matrix inverse is also identity matrix, and identity matrix transpose is also identity matrix. Then comes singular matrix. A matrix whose inverse does not exist, means determinant is 0. एक ऐसी मैट्रिक्स जिसका इन्वर्स इज नॉट पॉसिबल is called singular matrix, and its determinant is always 0. Then comes non-singular matrix. It is opposite of singular matrix, and its determinant A will not be equal to 0, means its determinant is possible and its inverse will also exist. Then comes symmetric matrix. If the transpose of a matrix gives the matrix itself, means if transpose of matrix is the matrix itself, then it is a symmetric matrix. And this is also transpose sign. Skew symmetric matrix it is opposite of symmetric matrix. If the transpose of a matrix is negative of the original matrix, because A transpose is minus A, then it is skew symmetric matrix. If A transpose is A, then it is symmetric matrix. Example, this is skew symmetric matrix. where A transpose is minus A. Here it is 3 and here it is minus 3. These are some of the properties of skew symmetric matrix. Diagonal elements are 0 and trace of matrix skew symmetric matrix is 0 and order is n into n, where if n is odd then determinant of A is 0, if n is even then determinant of A is perfect square. And a matrix can also be represented as sum of symmetric and skew symmetric matrices. If A is a matrix, then we can represent it as symmetric matrix sum and skew symmetric matrix. P is symmetric and Q is skew symmetric, where P can be written as half of A plus A transpose and Q can be written as half of A minus A transpose. Then comes orthogonal matrix. If A into A transpose is identity matrix, then it is orthogonal, and A into A inverse is equal to A into A transpose, then it is orthogonal matrix. Therefore, we can conclude A transpose is equal to A inverse, then it is orthogonal matrix. And the determinant of an orthogonal matrix is always plus minus 1. Then here comes involuntary matrix. If A into means A square is identity matrix and A into A inverse is identity matrix, or we can say A is equal to A inverse, then it is involuntary matrix. If A raised to power n, whereas n is a even power, then it always gives identity matrix. If A raised to power n and n is a odd power, then it will give the matrix itself, that is A raised to power n, where n is odd, then it is A. This is an example of involuntary matrix A 0 1 1 0 of order 2 into 2. This is involuntary matrix of order 3 into 3. So A cube is equal to A square and into A. It will give identity matrix into A, which is always A. Here power is even, so it will give identity matrix. If power is even, identity matrix, and power is odd, then matrix itself, then it is called involuntary matrix. For idempotent matrix, A into A should be A, that is A raised to power n. N can be even or odd. It will always return A, matrix itself, then it is idempotent. This is an example of idempotent matrix, where A raised to power any number, natural number, it will return the matrix itself. Then come nilpotent matrix. For nilpotent matrix, A square A raised to power n is equal to 0, means A can be any natural number, A raised to power n is always 0, then it is nilpotent matrix. Nil means 0. This is an example of nilpotent matrix, where A raised to power n is equal to 0. So thank you everyone. Please like the video and subscribe the channel and stay connected for more videos. Jai Hind.